coding problem solutions. This is this weekly contest of LeetCode, problem number 226 about k divisible element subarrays. If you later on thinks that this is valuable, please help to subscribe, click the like button, and click the bell if you want to be notified for further things, so that I know that I should be going on. And let's start. So we got an integer array nums with two integers k and p, and we are asked to return distinct subarrays that at most have k elements, at most element divisible by p. And this is the definition what it means by two array being distinct. Nums1, nums2, they are different length, or there exists at least one index where the value are different. So it means that the order of the values is meaningful here. Subarray is defined as a non-empty contiguous sequence of elements in an array. So there you go. It means that subarray is something you can build out of the nums by taking part of it, but you have to take it continuously. For example, you cannot take this and then combine it with this. You have to take all the way continuously. Okay, so we already have all the definitions. Let's see the constraint. For the constraint, length of nums between 1 to 200, p is less than 200, and so forth. Okay, so that is that. K itself at most is 200. K is the indicator at most how many member in the subarray that can be divisible. At most means it doesn't have to be 2. For example, let's see this. In total, the output is there are 11 subarray. The subarray was 1 is 2, 2, 3. In 2, 3, the divisible by 2 is only the number 2, right? So that is only 1. At most, we can have 2. That's why the first 2 is part of the solutions. 2, 3 still part of the solutions because this subarray is continuous and it has only one member that is actually divisible by 2. And if you notice, it continue on this one. And then it continue here. And this is still part of the solution because we only have 2 that is divisible by 2. And our maximum is 2. So this is still part of the solution. But when it goes to here, it's no longer part of the solutions because now we have 3 elements that is divisible by 2. So that's why we move on to here. And then here. 3, 3. And then 3, 3, 2. And so forth. So basically that's the idea and the rule of the problems. So whenever it reaches the point where the maximum is actually reached or breached, that's when we start all over. So the tactic here is pretty simple. Basically we loop it through, and then after that we can just do what it does. Whenever we met that it is the number of divisible element is bigger than the requirement, that's when we start back to the next element. Okay, now how can we kind of try to make this a little bit more efficient? The most expensive operation here will be the division. And if we do the what you call it, the scanning like that, basically the way we scan, if you look at it, we will scan it from here and all the way until the point we bridge the contract, which is the number of divisible is at maximum is k, which is in here too. Then we start back with a new starter. Just now we were stuck here, right? So the next starter is here. Then we scan it forward until the condition is met or we met the end of the array. Then we start again. So if you notice, there is an overlapping numbers that we already visited, and division usually in a programming is a more expensive operation than a simple additions or subtractions or valuations. That's why that's one part of where we can make the saving. So that's the tactic. Let's do the implementation. So remember that we want, I haven't explained how do we make the efficiency so that we don't do the divisions multiple times. Basically, we just scan through here and divide it. So we prepared another data structure that actually representing whether that thing is divisible or not. So we do the divisions only once, and then when we scan, we just refer to this resulted divisions, and then we can just use it. So maybe a little bit explanation of how we run it is like this. So what we do actually, we're going to convert it. Is this divisible by 2? Yes. Is this? No. Is this? No. Is this? Yes. Is this? No. Then when we scanned, whenever we want to check for division rather than dividing it, we just check here. Because otherwise, if you notice, there is an overlap, right? And we need this overlap because that could create a different combinations. Remember, we also want it distinct combinations, or distinct subarray. So that's why we still need to do the overlapping check. But we can save the division by pre-process everything and store it somewhere else first. So whenever we need to check for divisible, we just check what we pre-calculated before, rather than we do the divisions again. So let's do the concept. Basically, first, pre-calculate divisible condition for each of it. Let's call it is nums divisible. Okay, then for each n in nums, we just need to do if is divisible. Divisions, whether something is divisible or not, we can use modulo and check it if the result of the remainder is actually 0. So what happened here is we just need to do this. And the requirement of the divisions is the p, right? So if n modulo p is 0, that means it is divisible, then we can append the value to this data structure. Now we got everything pre-calculated. Now we do the scanning. And then what we need later on is the total count of the distinct subarray that is at most have only k, at most, maximum. That is divisible by p. So in the end, later on, we will return this total count. And the scanning will start from the beginning. We'll start from the beginning of the nums, and then it will do it up to the end unless it meant that the total count of divisible is breaching k. Count div initially 0. So whenever we found that the new nums is divisible, so the nums at j is divisible, if we find it that, then we increase the count for divisibility. But if the count of divisibility is breaching our requirement, which is at most k, so when it's greater than k, we break up. We break up and then start all over. When it breaks, we break up and start all over. I is the starter. Okay, but if it's not breaching yet, what we need to do is we need to check whether the combination is something distinct or not. So we need another data structure to help us check for that efficiently, which is we will use a hash dictionary here, which is an equivalent like a hash map in Python. So we need the nums from I to j plus 1 because this notation in Python is exclusive and we want all the way to the point j. So we need to plus it 1. We need to convert list, this is a list data structure in Python, into string because list is not hashable. So we need to convert it into something that is hashable so that we can check for it efficiently. And then we need to check if combi in visited. If it is already in the visited, we don't need to count it up. We can continue. But if it is not, then we can increase the total count. And also, not to forget, we need to journal it that we already met these combinations. Okay, so basically that's about it, how we implement it. Let's check whether this is working or not. This is 1110 1110, so that sounds correct. Let's submit it whether this solution is fast enough to be accepted, and it is. So that's about it for the solutions. Let's calculate about the time complexity for this. The first part is this. This is looping n. So this is big O(n). And for each of these we do division. So this is just a big O(n). And the scanning part here we loop for up to n. So this is a big O(n). And then we do this, and then this loop is another big O(n), and then here is just a check, just another check, and so forth. So at this point we have big O(n) here, and then because this is inside of this inner loop, this effectively make this into a multiplication, so big O(n) squared. And then at this point we have a addition because this and these are sequentials. And then for big O(n), when you have this addition, it means it becomes taking the maximum. So the time complexity is big N squared. That's about it. So if you have any questions or so on, just comment it out. Usually look at my comments once a week at the weekend. So yeah, hopefully this is helpful. Good luck.